The topic of our discussion is Introduction and Implementation of Fuzzy Logic, an AI technique in human decision, industrial and image processing. Our group members are Eeshan Chauhan, Ujwal Chikane, Vaibhav Maheshwari, and Avneesh Shukla. I am Avneesh Shukla. I will be starting the discussion over fuzzy logic. So we will discuss about the following agenda. These are what is fuzzy logic, why do we actually use fuzzy logic, what is the architecture behind the fuzzy logic, what is membership function, what are the differences between fuzzy logic and probability, and what are the similarities as well, application of fuzzy logic, what are the disadvantages and advantages behind it, and what are the realistic areas of application and implementation. So, what is fuzzy logic? Fuzzy logic tries to capture the human ability of reasoning with imprecise information. It models human reasoning. That is, it is a method of reasoning that resembles human reasoning and approach followed in processes similar to how human perform decision making. It works with imprecise statement as it involves all intermediate possibility between a guessed and unknown. Let's take an example for it. If the temperature is moderate and pressure is high, then turn the knob slightly right. We know that in conventional Boolean logic, as computer understands and take precise input and predicts output as true and false. Thus, in Boolean logic, computer won't be able to understand high, moderate, and low temperature and pressure altogether, and also won't be able to understand what is actually mean by turning knob slightly, as it can either understand moving it either right completely or doesn't move at all. But when it comes to fuzzy logic, you can use the same statement and can deal with the intermediate possibility, unlike computers. Human have different range of possibility between yes and no. So we do have certainty of possibilities at time. Thus, fuzzy logic was invented as it works from the level of possibilities of input to achieve a definite output. Talking about the implementation of this particular logic, it can be implemented in systems with different sizes and capabilities, such as microcontrollers. Also, it can be used in both softwares as well as hardware. Now, moving on, uh, we will talk about theory of sets. As fuzzy sets can be considered as an extension and grows over the simplification of classical sets. So there is an intimate connection between logic and set theory. For example, given any set S and an element E, there is a very natural predicate mu of set S of element E that is called as belongingness of that predicate, such as mu of S of that element E is equals to N if that particular element belongs to the set, otherwise it is zero. For an example, we can see we have a set S in which the elements are 1, 2, 3, 4. So mu S of 1 will be 1 because 1 belongs to that particular set, and mu S of 5 will be 0 because 5 does not belong to that particular set. Also, we can define a set naturally by predicate P of set S such that set S is equals to X given that P of X is true. For example, even of X defines set will be X when X is even. Now we will move on and we will talk about theory of fuzzy set. In set theory, we have this assumption that the value of belongingness predicate mu equal to either 0 or 1. Instead, in fuzzy theories, it is assumed that the belongingness predicate mu S of E for an element E can have values from between 0 and 1, including 0 and 1. Thus, fuzzy set theory is a generalization of classical set theory, and it is also known as crisp set theory. In real life, belongingness is a fuzzy concept. For example, let T is equals to set of tall people. So mu T of Ram will be 1, mu T of Sham will be 0.2. It means Sham belongs to T with degree 0.2. Now let's see, why do we actually use fuzzy logic? Uh, Generally, we use the fuzzy logic system for both commercial as well as practical purposes. It can control machines and consumer products. Also, at a time when you face certainty between yes or possibly yes, it's not given accurate reasoning whether answer is yes or no, but at least it gives an acceptable reasoning where you are saying that it might be or it can happen, something like that. So if not correct reasoning, at least it provides acceptable reasoning. It also helps in dealing certainty, uncertainty in engineering. So in case you are unsure or you don't know if a statement can be yes or no, it can still find a middle path, that is where it can help in dealing uncertainty. Now I would like to hand over to Ishan to talk about further.
Hi, I am Ishan. So now I'll be talking about the fuzzy logic architecture. In this fuzzy logic architecture, it takes an input as a crisp input into the fuzzy fire, and then that gets converted into the intelligence using the fuzzy input set. And this intelligence is based on some rules, and which then gets converted to the crisp output through a defuzzifier, which uses the fuzzy output set. So now I'll be explaining these terms into more depth. Like rules, rules are the if and then conditions offered by the experts to control the decision making system. The recent update in the fuzzy theory provides the different effective methods for design and tuning a fuzzy controller. Usually, these developments reduce the number of fuzzy rules. Fuzzification step converts the inputs or the crisp number into the fuzzy sets. You can measure the crisp inputs by sensors and pass them into the control system for further processing. It splits the input signal into the five steps which are discussed as follows. The LP, which is when the X is large positive, MP when X is medium positive, S when X is small, MN when X is medium negative, and LN when X is large negative. So we'll be moving forward with more terms like inference engine determines the degree of match between fuzzy inputs and the rules. According to the input field, it will decide the rules that are to be fired, combining the fired rules from the control actions. Defuzzification process converts the fuzzy steps into the crisp value. There are different types of techniques available, and we need to select the best suited one within expert system. So this was all about the architecture of the fuzzy logic and the terms related to the fuzzy logic in AI. Now let's just understand what is a membership function. So a membership function is a graph that defines how each point in the input space is mapped to the membership value between 0 to 1. Uh, it allows us to quantify the linguistic terms and represent a fuzzy set graphically. A membership function of a fuzzy set A onto the universe of discourse X is defined as mu A, which is then contained into X from 0 to 1. It quantifies the degree of membership of the element in X to a fuzzy set A. These is presented on the axis, where the x-axis represents the universe of discourse and the y-axis represents the degree of membership in the 0 to 1 interval. There can be multiple membership functions applicable to fuzzify a numerical value. The simple membership functions are used as complex functions that do not add precision to the output. The membership functions for the values that we discussed, like LP, MPS, MN, and LN, are like basically defined through a graph which is presented as follows, where the x-axis represents the input temperature and the y-axis represents the membership function. The x-axis has the limit from 0 to 40, whereas the membership function has a limit from 0 to 1. These triangular membership function shapes are most common value various other membership function shapes. Here the input to 5 level fuzzy fire varies from minus 10 volts to plus 10 volts, and hence the corresponding output also changes.
This is Ujwal, and now we are going to study what's the major differences between the fuzzy logic and probability. So, in general, the fuzzy logic basically try to capture the essential concept of vagueness, and while the probability is associated with events and not facts, and those events will either occur or not occur. In short, like fuzzy captures meaning of partial truth, while the probability theory captures partial knowledge. Fuzzy logic takes the truth degree as a mathematical basis, while in the other case, probability is mathematical model of ignorance. Now, let's move to the other one, the application of fuzzy logic. So there are various applications from automotive system to domestic goods to environment control to etc. So let's see some of the most common applications. So it is used in the aerospace field for altitude control of spacecraft and satellite. It also controls the speed and traffic in the automotive system. So majorly it is used in automotive and the vehicles. Third one, it is also used for decision making support systems and personal evaluation in large company businesses. It's also controls the pH, drying and chemical distillation process in the chemical industry. Most advances usages of fuzzy logic is used in natural language processing and various intensive application in artificial intelligence. Also, it is extensively used in modern control systems such as expert system. Fuzzy logic mimics how a person would make a decision, only much faster. They use it with the neural networks. So now advantages of fuzzy logic. So this fuzzy logic comes with both advantages and disadvantages. So let's go through advantages of fuzzy logic briefly. So fuzzy logic provides simply reasoning similar to human reasoning, and there are more such advantages of using this logic, such as the structure of fuzzy logic system is easy and understandable. Fuzzy logic is widely used for commercial and practical purposes. Third one is it helps you to control machine and the consumer products. It helps you to deal with uncertainty in engineering, and this is the major advantages of fuzzy logic, that it's the uncertainty here is very low. Mostly robust has no precise input required. If the feedback sensor stops working, you can program it into the situation. You can also easily modify it to improve or alter the system performance. And the last is the inexpensive sensor can be used, which help you to keep the overall system cost and complexity low. So yeah, the fuzzy logic sensors are cheap at cost. Now, the disadvantage of fuzzy logic. So everything comes with advantages and disadvantages. So here are the disadvantages of fuzzy logic. So some disadvantages are there. So fuzzy logic is not always accurate. So the results are perceived based on the assumption and may not be widely accepted. It cannot recognize machine learning as well as neural network type patterns. Third is the validation and verification of fuzzy knowledge-based systems need extensive testing with hardware. Setting exact fuzzy rules and membership functions is a difficult task. The last one is at times the fuzzy logic is confused with probability theory.
Now we will be taking a look at the areas implementation of fuzzy logic. These include industrial control, human decision making, and image processing. Now, firstly, we will be taking a look at industrial application. Here, we are taking a look into marine diesel engines. The objective here is to control the speed of diesel engine such that the fuel cost is minimum. All the external factors the will impact the instability of the diesel engine speed. These include wind, wave, and tidal currents. Furthermore, the fuel consumption is also dependent on the speed of the engine. In result, we will be taking diesel engine speed error and variable speed error as two major inputs and giving out the speed of diesel engine as output. Now we will be taking a look into human decision making, that is the Volkswagen direct shift gearbox. Here the objective is to control the gear such that the present speed and the style of driver are taken into consideration. In this case, the vehicle speed, change of speed, slope of resistance, and accelerator are the major inputs for fuzzy classifiers, and and driving style is taken as major inference system, engine, and the gearbox is given output to the car driving speed. Now we will be looking into image processing part. Here the intent of the classification is to divide the image into three important parts: nucleus, lumen, and cytoplasm. Here we will be setting the number of classes to 3, then initializing a fuzzy description for each, and find the set of fuzzy description for each with the lowest overlap. Here we can see from the image that the nucleus is red and black, lumen is green, and the cytoplasm is in yellow. Thank you everyone.